All right, so once again, welcome to today's webinar. And today's webinar, we'll be talking about DevOps, so breaking down DevOps, talking about the integrity of DevOps. And we have an expert in the house that will be asking questions that will give you more insight, give us more insight on DevOps and how to also tap into DevOps and also join the flow for people that want to migrate from software development into DevOps, and so for people that are already just trying to even not software development now, maybe from other kind of walks of life and trying to move into tech, but the third place of is DevOps. So we'll be talking about that. And this webinar is brought to you by brought to you by School.io. School.io is an edutech platform that is building a space where everyone in Africa can have the opportunity to equip themselves in the best way, in best tech tools and practices. And our focuses are always in cloud engineering, DevOps, machine learning, and cybersecurity. So so we're talking more about School.io maybe by the end of the session. So I can see if you can drop in the chat just where you are joining us from, so that we can know where people are joining us from. Just comment on the question. I'm joining from Lagos in Nigeria, so we can just drop in on that while the session is going on, where you're joining us from. Thank you so much for joining us once again. So we call on Mr. Ogbede, God's time. Sorry, I don't know the surname. I will try and pronounce it. Seme Ken. I don't know. Did I get it right?
Yeah, you were close. Good
I
evening.
tried.
I give you 2/10.
Oh, sorry.
Hi, good evening.
Yeah, good evening.
Everybody. I wish waiting for people, or can just
Yeah,
start.
we can. So we are ready, like, so we can. People will be joining us
Okay.
that continue because we're already it's already 10 minutes past 7.
All right. Good evening again. My name is Obeidi God's time or Semehia. I checked the participant. I've seen a lot of senior engineers, and yeah. So disclaimer. So what we're going to be doing here is what we have learned in our own few experience based on hands-on working with startups and then enterprise organizations. So yeah, when we are digressing, the seniors in the house can always chime in on the chat and see one or two. All right. I made a small Google slide
Okay.
because when I'm talking, I know I've noticed that I digress a lot. So the Google slide will just guide us. Yeah. So can you see my screen?
Yes, we can.
Okay. So we'll just start, right? Again, my name is Obeide. Most of my friends call me GT. Yeah, so currently I'm working as a DevOps engineer, senior DevOps engineer in a company. I'm not mentioning the name because mostly I freelance too. So yeah. Okay, so this is just a brief introduction about me. Our topic, what we'll be discussing is DevOps Demystified from brilliant basics to brilliant, and with treating a journey through automation and collaboration. Yeah, this is me. So Jin Kim, co-author for this book. If you've had the opportunity to read read that book, or if you have not, you can research this book, the Phonics project, and then DevOps handbook. Said DevOps is the professional and cultural movement that stresses communication, collaboration, integration, and automation in order to improve the flow between software developers and IT operations. So when we come to the word of DevOps, I think from the word DevOps is development and operations, and then it's combining these two stack to make a one. So there's always the ideology that a DevOps engineer is the person that actually does both development and then operations. So that's why you see in many JDs, you're saying that the DevOps engineers should have 5 years experience writing Java, Python. Then from there you move on to DevOps tool sets. Yeah, but I think that's a misconception, and hopefully we can clarify that misconception today. So today we'll be treating these various outlines quickly. Principles, DevOps introduction, principles, tools and technologies we use as DevOps engineers, then security. I did a case study. I just did a DevOps flow diagram, and then we'll just walk through it. And then if time permits, we can treat career roadmap. Okay, so let's get to it. DevOps started like 15 years ago. Maybe in fact there was actually a revolution, and the idea is to pop it up, but I think officially the Patrick Devops was the first person to like use the word, and then the culture, the campaign, that word was coined and then adopted around 15 years ago. That was like 2009. And it was stemmed from silos in development and operation. So before, what happens is a team will have developers, the actual core developers that write code, Java developers, you have C#, you have C++, and then backend and other frameworks, those other languages. So there were those guys. So those guys, what they do, they write the applications, and then bundle the application up. For Java, they give it to the operations guy, the ops guy, as a jar or a WAR file. And then is that ops guy, IT guys that know what to do with the application. So before there was no ways to actually define how to run it. So the IT guys will have to like carry the application and then try to figure out how to make the application run. And then finally they get it to run and then manage the application. And this process takes like about more than some of this process could take more than years, some can take months, some can take weeks to release a feature. Probably your application had a red button and then you want to change it to green. You can like wait for like the next 2 months to do that. So that was what was the initial challenge, and then what brought about people clamoring for a process, culture to actually streamline this process. So there was a set of practices that combines development and software, IT operations. It aims to shorten the software development lifecycle. This is the narrow, it's not system. It's software development lifecycle, SLDC, and provide continuous delivery with high software quality. So with DevOps, when DevOps came, so DevOps seems to bridge that gap, the gap between when the developer completes his code and then passes it to the operations team, and then operations team packages those code, bundles, they deploy them, prepare the server, the environment the code will run on, and then the operations team comprises of before it was system administrator, there were testers, the quality assurance guys. So operations team comprises of those guys. So from the point the developer codes that application to that point. So DevOps actually shortens that gap in the sense that we the DevOps culture enhances collaboration. So we developers and operations guys are no longer working in silos. They are working together, and then DevOps is bridging that gap. Yeah. So as a result of bridging that gap, many benefits accrue. So because there's DevOps has reduced the time it takes to actually release a software product. There is accelerated software delivery. So DevOps help organizations to make their software releases very fast. Like you can have a feature, probably we want to change this zone background to default background to black. So when we join a meeting, is black background we're saying first. So with DevOps, we can actually do that depending on the workload. We can actually do that in probably, if the team is a very large team, 1 week, 2 weeks, 1 day. So depending on the team, instead of having that, then you log it to ServiceNow, and then they look for developers to code the application. Developers code the application for number of months, weeks that they can complete it, hands it to operation starts having their own silos of tasks to do. DevOps creates a platform where these guys can come together. As you're writing the code, there is process that is doing continuous integration. From there, testers and QA and quality assurance engineers has written their automated test scripts and then handed it over to the DevOps engineer. And DevOps engineer will infuse this script into the application so that when the application is running, as developers make a change, probably changes a feature based on specifications, it pushes the pipeline that DevOps engineer will create, runs, and then when the feature has actually been merged to the application, the automated tests are being run against the code that the developer has just integrated. So instead of having developer complete that phase, so each bit of code developer runs is being walked through and this whole DevOps life cycle. So as a result, there's also increased reliability and stability, because as you're coding and then those pipelines, those structures are in place, if there's error, you will catch it in time. And then if you catch that error in time, you communicate to whoever is responsible, the stakeholders, that okay, your code, we are getting this stuff in the log. The stakeholder carries that log you reported and then works on it and look for fix to fix it. So there's improved communication. Like you are actually serving, DevOps engineer is actually serving as a middleman, not like in business world, but in technology, in the sense that you are you fixing processes to actually do this. So you can actually in your software delivery, you can have comms like bots for Slack, and then your collaboration tool, you are using Teams, and then when developers make a push and then that push phase, the automated reports, the developers get a mail or a pager or a message on the Slack channel and say, hey, Laji, your push got denied. And also, so because of that, there's reduced cost. So for DevOps, these days, modern DevOps actually encourages public cloud usage. So you reduce capital expenditure. So you have your infrastructure, you can always bring them up and bring them down instead of buying racks of server, and then those racks of server, if you don't need it again, you probably have to like use this for a colocation center. or they'll be useless to you. But with modern DevOps that actually encourages public cloud adoption, you can actually decommission and recommission your infrastructure with a click of a button. And also, because your development cycle is reduced, I think I'm wasting time on this slide. Because the development cycle is reduced, you actually make more money in development instead of having that long time to wait. And that long time you're waiting, you're paying your engineers for the man hour they work. But if we're releasing a product and the release cycle is like 2 weeks, in that 2 weeks, we're expecting that the product gets on market, and then from that 2 weeks, start making money and you are getting value. And then there's enhanced satisfaction for both the organization you're working in as a DevOps engineer, and then the clients your organization is serving, or your customers. So principles of DevOps. So DevOps is a culture that brings development and teams and operations teams together, like we've already established. Yeah. And in DevOps, there are some principles that we adhere to. In different organizations, they have different names for this principle, but the principles still revolve around collaboration, automation, there's continuous improvement, there's customer centrication, customer-centric action, like customer centricity. Then there's build with end-to-end focus, like you're building and then you have the end products in mind. And then as a DevOps engineer, there's the principle of you embracing failure. Yeah. So we'll just treat them real fast. Let me check my time. Okay. We have time. So collaboration is a key aspect of DevOps. It helps to foster effective communication and teamwork among development team and operations and other stakeholders. So it helps to break down silos. So these silos we are talking about is barrier, like barrier in the software delivery or development process. Yeah, so collaboration helps to break these silos and then promote cross-functional teams. So with this principle, collaboration is the DevOps principle, you can have teams in different region and teams in doing different things. For example, you can be building an app that has mobile, web for parts, and then that mobile, you have Android and iOS. So you can, with DevOps, all the teams, the mobile guys, the iOS guys, the React Native, Next.js guys, and then people building the backend can all collaborate together, and DevOps foster that. So the benefit of collaboration is improved communication. Normal, if we talk, if there's a room or there are mediums for us to talk. So when there's issue, I can always call you and say, Jeffrey, there's issue with your code. Then you can always go back and look at the issue and then fix it, and then the next process move. So improve communication and coordination between teams. Then there's faster feedback loop and then shorter development cycle. They increase efficiency and productivity. There's greater alignment and understanding of goals and priority. And then enhanced quality and reliability of software products. Then another other DevOps principle we just treat briefly, customer-centric action. So DevOps team employ brief feedback loop with customers and end users to create product and services tailored to users' needs, so that satisfies your customers by using real-time live monitoring and then swift development. So what this principle says that as DevOps engineer, you help to you are customer focused or client focused, in the sense that for your development lifecycle, for example, your software delivery process, if a feature you have implemented, or the team has implemented, for example, a business wants like that Zoom example I gave initially, a business wants their the Zoom icon to be black, and then you made it black, and when they check, it was not appealing to their face, and then they might feel that they will lose money. They can come back and say, we need it to be blue. So DevOps culture is actually you are customer centric. Like it is what the customer or the business, as a DevOps engineer. So your customer are the people you are working for. That's the organization. For example, if you are working for organization XYZ, the customer, and then the customer's customer. So you are tasked with, the principle is that you focus on delivering to their satisfaction. Then another principle is build with end-to-end focus. So this principle revolves around grasping customers' need and crafting product and services that genuinely addresses tangible issues. So this customer-centric action relate. But the customer-centric action, sorry, if you cannot hear me, just let me know. And when I'm audible.
No, we can hear you. We can hear you.
Okay, thank you. So the customer-centric is that you have a feedback loop, that you get real-time feedbacks on your practices, on the team's practices from the people you're working for or for the product you're working on. Why? For build with end-to-end in mind. For example, so the principle revolves around grasping, what the customer wants, and then working, creating processes to actually deliver it to satisfy the customer exactly or more than they've paid for. Yeah, let me use that word. So in the sense that if a customer wants an iOS and a an Android app, as a DevOps engineer, you make sure that they get that in this, and by creating processes. For example, your iOS application, as a DevOps engineer, it must first of all be free of vulnerabilities. Then it must meet security standards, and then it should be free. It should not have a surface of attack. For example, if somebody wants to hack the application you just deployed, you've just released to your customer, should not be an application that somebody can just run SQL injection on or doing some OSS attack on. Yeah, as DevOps engineer, you factor that into your development process and try to cater for the customer's need. Then another principle is continuous improvement. So in past DevOps, so in the past software development teams, they aim to release perfect products from start. So that's why before, the engineers, the developers, we carry the application and then write the code from beginning to the end, and then passes it to the next team, the ops team. Then the ops team do their own process too, and then make it operable, right? So that process resulted in delay, like we have established. So DevOps encourages incremental releases, feature by feature. And DevOps is quite very almost related with agile agile mode of development. Is, in fact, sometimes they are the same thing. Yeah. So DevOps encourages incremental releases of products. So this is what the principle teaches, that teams should constantly focus on making their product much better through upgrades and new features. Another principle is embrace failure. So this principle, in DevOps, technologies and toolings are always evolving. So DevOps principle states that you should not be afraid of failure, because these two, like the Terraform version that people were using in 2010. 2010 is too far. 2015, 2018, even 2021 will be different from. So there are so many Terraform modules that are doing so many other different things now. Like an implementation I was trying to do the other time with Terraform module for AWS Amplify. I saw one implementation that was done in 2021, and then it was returning error because some of the what's it called? Some of the names of some services has changed. Even same with code, same with code. So some libraries would be deprecated. For example, if you're using a library for Java 17 or Java 8 for some technologies, it not works. Say, let's pick an example from AWS Lambda. So AWS has deprecated, I think, Node.js 12, version 12. Yeah. So with that, since that's deprecated, as a DevOps engineer, if it's your tooling, you are always evolving, trying to be up to speed with the new versions of the technologies you are using, or new technologies that will make life better for you. For example, if your team probably were building with Jenkins, and then your tech lead just wake up and say, guys, let's move to GitHub Actions. And you as a DevOps engineer, you've not used GitHub Actions before. So DevOps principle is saying you should not be afraid to fail. You should not be afraid to run down your first pipeline and then return so many errors and red lines that you don't even understand. Yeah, you should try and then be abreast with latest technologies. And how you do that is by learning. And then learning the first time, you will not always get it. You might not always get it the first time. Let me not use you will not always get it. You might not always get it the first time, right? So you embrace failure, you fail, you try again, you fail, you try till you don't fail, till you become a master of that technology. Like, let me just read what I wrote here. As software being produced improves on continuous basis, so the process used to create it. So a key to achieving such flexibility is to encourage risk-taking and then embrace failure and view it as an opportunity for learning and improvement. So we'll go to the next slide. Oh, sorry. All right. Another principle. This principle, I don't want to say is key, is automation. So you see, we've established that DevOps engineers actually make software delivery easy. How we do this is by automation. So in DevOps world, DevOps engineers and teams are encouraged to automate anything that they can automate. Like the process of creating your infrastructure, the process of linting codes, the build process, the testing, the deployment, the decommissioning of your infrastructure should be automated, so that it reduces manual efforts and errors. So automation plays a crucial role in DevOps by enabling the rapid and then reliable delivery of software. It helps streamline and accelerate various processes involved in software development. This gives developers more time to write code and develop new features. With this, we get increased efficiency, scalability, improved quality, consistent and reliability. Then some types of automation include, there's build automation. Okay, I was mentioning this before. There's build automation, there's test, deployment, and monitoring automation. Then there's infrastructure automation. Here, there's infrastructure as code, and then configuration management. Then there's monitoring automation. Here, you automate the monitoring of your software. So this one, monitoring automation is creating processes that watches your infrastructure in real time. For example, using a monitoring tool, so you can set up monitoring tool like Prometheus and Grafana open source, AWS CloudWatch to monitor your infrastructure. So it's automated in the sense that when those infrastructure are in place, your application hits, you can have it in the dashboard. So when there is issue, when there is a new log, you see requests, you see the logs of your application in real time, and then you can view them. So that process is automated. You don't have to like say when application is having issues and the team runs to you and say, we cannot see this. So you now go to your server to check logs and then come back to say this is what's wrong. Instead, you automate the process, you create processes that helps you check these things, and then you can actually give business access to probably visualization dashboard, Grafana dashboard, a Kibana dashboard, and then if the people are technical be, you can create an IAM role for a CloudWatch metric dashboard. So in automation, we do majorly two things in as DevOps engineers. So we do continuous integration and continuous delivery. Yeah, they can also add continuous deployment, but it can just be delivery and deployment, but it's still the same flow. So continuous integration involves merging code changes into a shared repository frequently, followed by automated build and then test process we have mentioned in the previous slide. So it ensures that the code base is always up to date and minimizes integration issues by detecting and resolving conflicts early in the development cycle. This one is self-explanatory. So this continuous integration is the process whereby developers and everybody working on the application, let me just call it application, the software product, have a place they collaborate together. Majorly in DevOps world is Git, a version control system. So, and enterprises, what they use majorly, some can be using GitHub. GitHub is a Git-based version control. There's GitLab, there's Bitbucket, and there's Azure repos. Then there are other tools. Yeah. So there's Git, there's Subversion, and then Mercurial. But the very, very highly used version control is Git because of its flexibility and then how it handles branching, merging, and then collaborations. Then there's continuous deployment or delivery. Continuous delivery extends continuous integration by automating the deployment and release process. So here, in continuous integration, what you do is you to as a DevOps engineer, you create a pipeline for build and test in this place. So that when the developer is working, their code changes are continually built against what is on the main or release branch. For example, you are using a trunk-based system, a branching system, and then you have your master branch. Your pipeline, before anybody can merge to your master branch, your pipeline have things in place to always build the code. So the code on the master branch is a working code. So whenever anybody wants to add any features to that code in the master branch, the pipeline builds them together and compile it and see if there's error. So if the code compiles successfully, the developer can merge his addition to the main source. Why for continuous deployment or delivery? This is where after the features has been developed, and then this build process and test process is completed, then this process is an automated deployment process. So it can be using different method like blue, green, canary, and what you have. So for this part, so it focuses on ensuring that the software is always in a releasable state with automated testing, configuration management, and then deployment pipelines in place. So towards we're closing. So we'll just rush DevOps tools and technologies. So in order to support DevOps practices, there are various tools and technologies available in the market. The tools are inexhaustible. As a DevOps engineer, I think you will always meet new tool. Yes. Currently, in a project I'm working in, we have like 4 new tool. I just heard about them last week, and we have to implement. So as a DevOps engineer, that is how it is now in our doings. So you always meet new tools. You will meet tools you've used before. You will see tools you have idea on how to use. So you must be flexible and then quick to learn. Even if you are not quick to learn, at least meticulous to learn, even if it's slow to learn, but you must be ready. Okay, that's the word. You must be ready to adopt and adapt new technologies. So some of these few tools are on this table. So common tools, DevOps tools, and technologies. So you have category and example. For version control, we have Git, sub version, and Mercurial. So version control is the system where that helps code to be integrated by various developers, so they can work easy. They can work on a system in their own system, and then the code will be existing in a single place, like a Git-based version control, for example, GitHub, and then developers will collaborate and then um, push their code changes to that place. So version control enables that. And then Git, Subversion, and Mercurial are examples of version control. Then there's continuous integration and continuous delivery tool. So some of the continuous integration and continuous delivery tool are Jenkins. As Even if you're not a DevOps engineer, you would have heard of Jenkins, because Jenkins has been around. Sorry, Jenkins has been around for quite a while. I think almost close to since the beginning of DevOps. Then there's Travis CI, there's GitHub Actions, there's Azure DevOps, there's AWS Code Pipeline, there's Cycle CI, it's now here. There's GitLab CI, there's Bitbucket pipeline. Yeah, they are quite various continuous integration and continuous delivery too. So the choice of this depends on your organization or your software delivery teams. So some organizations will say they are using Jenkins, and that's what you have to use. So then others will say they are using Travis, they are using GitHub Actions. But yeah, these are the tools for doing continuous integration, continuous delivery. There are more, like is inexhaustible. Some some organizations build their own CI tool and then use that. So there's configuration management tools. Example Ansible, Puppet, Chef. So configuration management tools, I think they came before infrastructure as code tool. Did I capture them here? No. I should have added them. So there's infrastructure as code tools, then there's configuration management tool. So for configuration management tools are used to configure, or let me not use that word, install dependencies and packages, or update the environment where application is running in. For example, the environment can be a Linux machine, can be a Windows machine. Yeah. So For example, what you would do with Ansible is after you spin up your Ubuntu, probably AWS Linux 2 image EC2, you on your pipeline, you configure, write Ansible script task to and rows to maybe one task will just do apt get update to update that brand new image. Then another task will probably be installing Python. Another task will probably be installing PM2 and so on and so forth. Another task might be installing Docker, right? So that's what Ansible, Chef, and Puppet does. Then there's infrastructure as code tool. So those are the tools used to spin up the infrastructure. For example, in our case, the EC2 Linux machine. So if you write, and those tools are example of infrastructure as code tool, you will always meet Terraform. Then Terraform is like most organizations' choice because it's not cloud agnostic. Like it's not dependent on, you can use Terraform on any cloud, whether GCP, AWS, Google, Azure, DigitalOcean, name them. They will always have Terraform provider for those cloud platforms. Then for cloud platform IAC tools, we have CloudFormation for AWS, we have ARM templates for Azure, we have Google Deployment Manager. I think I've used it once. That was a long time ago. Yeah, we have that one. And then there's Pulumi and a couple of others, very few couple of others. So that's so you write your Terraform to spin up that server, and then probably you can use a Terraform provisioner to actually also do configuration management. But after you use your Terraform to provision your instances, EC2 machine, then on that your pipeline, you can query for the IP of that EC2 machine and then pipes it to Ansible. The Ansible uses that as host and then log in your EC2 machine and then do those Docker install Docker, install all the dependencies you want, right? So another tool is containerization platforms. So containerization is the process of bundling your application code into a container. Yeah, permit me to use that word. So that you can, the advantage of containerization is so that you can move your application around and be flexible with it, and then also to actually help reduce environment dependencies. For example, your developer might be using VS Code, and that person might be using another IDE, and then to help prevent ensure consistency in deploying the application, we containerize it. So examples of containerization tools there, we have Docker, then we have Podman. So these guys actually are the main containerization tool. So Docker, you write the Docker file to containerize your application, and then same for Podman. Then for Kubernetes, AWS ECS, then there's Docker Swarm, there's Azure Container App Service, there's ECS, yeah, and the likes. What these guys do is help orchestrate these containers, these Docker and Podman containers. There are also other containerization technologies. Yeah. So we have monitoring and logging tool. These guys helps to automate monitoring process, like we mentioned in previous slides. So examples are Prometheus, we have ELK Stack, Log, ELK Stack is Elastic, Logstash, Kibana. So Elasticsearch is what queries for the log. Logstash packs the log and then hosts them. Then Kibana visualizes, gives you a visual dashboard of the metrics and what's the health of your environment. Then there's CloudWatch, there's Datadog, AppDynamics, and there's Azure Monitor. Then for collaboration tools, we have Jira. Collaboration is where the teams chat, engage, talk, and discuss. Yeah. So for example, we have Jira, Confluence, Slack, Team, Google Workspace. It can be email, it can be WhatsApp, depending on what the team chooses. We're almost out of time. So another part I to talk about, just watch this, is security in DevOps. So as a DevOps engineer, you actually must ensure that you bake in security in your development process, from the infrastructure security um, to your code scanning, to continuous monitoring, to preventing vulnerabilities, preventing layers of attack in your application. So from the whole of DevOps, the application software development lifecycle, you are responsible for enhancing and ensuring the security in all of those processes. And also, when user click your, for example, schooling devopswebinar.com, when a user clicks that to buy probably a toothbrush, the user will not be proceed to a scam website and then the user loses money or loses information. So you manages all of that from code. You ensures that your code is free of vulnerabilities by infusing in vulnerability scan using oh, it just came and left. You can use GitHub Advanced Security Scan, then Sonar Cube. You do OWASP, that's you do static code analysis and dynamic code analysis. Then from there, you're integrating WAF when you have released it, that's a web application firewall. You're integrating Shield, you're integrating firewalls around anything you're doing. Then you're making sure that who best practices for IAM is being followed. So if I need to only access server, I should only have permission to access server. And then you are also implementing logging of using CloudTree or other cloud services to check who is doing who in their in your environment. So DevOps is tasked with that role. So we'll not have time to treat this. This is a sample DevOps flow. So it works from development to code peer review to QA to pre-prod, and then when your application is in production. I would have like talked about what happened in these stages, but from what we have been saying, we should have a view of what happens in the flow. So for career roadmap, I think schooling, we give you something, but you can also look at this link to see a lot of stuff you can how you can start. It's quite a lot, and then I know starting you need hand holding. It's very important. If you don't get hand holding, you be learning for like 4 years and gas out. Yeah, you need a mentor. Yeah, I think that's what school is doing for the guys. So I think on final notes, this emoji when I was adding it, I was looking for how to explain, but I don't have time to like play with my emojis. So we've got a lot of concept, but we cannot exhaust all about DevOps. DevOps journey is ongoing, and there's always more to explore. Whether you're taking your first step or a seasoned practitioner, the world of DevOps is dynamic and evolving. Continue to learn and improve as you work the DevOps path. Thank you. Yeah, okay. I think this is the end of my talk.
Wow.
So
Wow. Wow.
any questions?
What a
You can-
session. I mean, everybody's just looking for, so everybody's looking for towards the end of the presentation. It has been a very technical session. Thank you so much, Godstein. for this comprehensive, because everybody can, I think everybody can attest to that. It's a very comprehensive breakdown of DevOps, like entire lecture on itself, giving the background, which is even useful for people that are just trying to understand DevOps, what DevOps is all about. I think it's a session that has given me an eye opener, right? So, and also for even for people like us that are also being in the field, be able to learn one or two things. So while I try to recap one or two things that he has said, then if you have questions, you can put it on the comment section. If you have a session for Ghost time, you can put it on the comment section. Like you said, one of the core courses that we take in School.io is DevOps, and we have a course starting February, another course starting February 26th of this year. So we already have one course running, and we have another course that will be starting February 26th. So you can check up our website on school.io. That's just it, school.io. That's the website, so you can check up on that to learn more about the course. So if you have questions, you can drop it on the chat. He has spoken about from the genesis of DevOps. 2009 spoke about the life cycle of DevOps, in terms from code to build to test to release to deploy to operate. They have spoken about the benefits of DevOps, includes accelerated software delivery, increase reliability and stability, reduced costs, improving collaboration, communication, which is very key. Because if you're a software developer, and you are working with teams, and at times you want to sync everything, you want to synchronize everything together, you want to work with teams, so DevOps make all those things easy. In terms of automation, it also makes it very, very easy for you to do. So, and also the principles of DevOps, which is very, very key, is collaboration, automation, and continuous improvement. So he spoke about a lot about you make money for God's to add. Okay. All right, so he has given another tip. Another benefit is you make money. So he forgot to hide that. Money. So it's also very critical. So, but he has also spoken about continuous learning and continuous improvement, because in the space of tech, at every point in time, you always be learning. So it's not something that you just learn something out, because I already have I already know Jenkins, I know uh Kubernetes and Terraform, a little bit of CloudFormation, AWS, and I just relax and feel, oh yes, have arrived. So it's more of constant introduction, like he said, in his organization, they just introduced 4 new tools that he has to learn, he has to go and do that. So he has done a lot of that. He has dived into a lot, and security, very, very key. And he has also dived into a lot of security. I spent so much time. So very insightful, very clear, very, very concise, very, very detailed in presentation for that. So questions, I'm waiting for questions. If you have questions, I'll ask questions. I'll ask questions. All right. So if there's a question, okay, for my own side, so Ghost time, I'd just like to ask for the benefit of everybody. For you, from your own experience, how have you been able to handle the situation of working and also continuously learning new tools and new softwares, new applications that are critical to your role as a DevOps engineer? How have you been able to handle that?
Oh, okay. I won't lie. It's very continuous learning is very, very difficult, right? But it's intentionality. You have to be intentional. And then as an engineer, what I encourage most people do is have a schedule, right? So if you don't have a schedule, you just work, especially if you're working remote, you just work from morning, you start working from 8, and then before you know, it's 10 p.m. But if you have a schedule and then set alarms to say, okay, this is what I want to learn. For example, you are constantly, as a DevOps engineer, you're constantly looking for new technologies, improvements, and then how things are being done via LinkedIn, via posts, via web blogs. Yeah. So you pick learnings from that and then set time out to actually look at the tools. Thank you.
All right, thank you. So another question, just pop in now. So what's the difference between a cloud engineer, a DevOps engineer, and a system administrator? I have been seeing job description and they can just get confusing.
Okay. This person that asked this question wants to set me up. All right.
Yeah.
I think currently, we don't know. You know why? Because JDs have evolved, right?
Yeah.
But a DevOps engineer is the person that does that helps ensure DevOps culture is being carried. So DevOps culture is majorly automation, collaboration, and those other things, right? Why a cloud engineer is somebody is a professional that works, has knowledge, and then works with cloud technologies like AWS services. I think in structured way, I think there was a seminar I attended last period. A structured way, we have AWS cloud engineer role. There will be Azure cloud engineer roles. Then there's Google cloud engineer roles, right? So there's even a Kubernetes engineer. So there are so many, so those guys work with those technologies. So if you're Azure Cloud Engineer, you work with majorly Azure Cloud technologies. Why system administrator, the old guys that used to be, what they do is configure server, do networking, yeah, all those kind of function. But these days, why I said I don't know is that you can have a JD for a cloud engineer, and then the job functions there are the roles of a DevOps engineer. You can have DevOps engineer role, and the JDs are role of a cloud engineer. So yeah, it depends on the organization. I think that's what the organizations now determine what those roles do.
Yeah.
So there's no one size fit all.
Yeah, thanks for that clarity. So to just buttress that, yes, looking at job descriptions on LinkedIn can be very confusing at times because at times they just pack all the both the one that they will use and both the one you learn on the job, both the one they don't need now. Just pack it, no pack it there and everything like that. Just put it like that. But it's very, very critical that a background in understanding of cloud, you know, certification in cloud, maybe yeah, maybe AWS. We are focusing on AWS, Azure, or GCP certifications in maybe to even understand the architecture of the cloud system and some artificial certification in maybe in Terraform, Kubernetes can come in later. Yeah, very, very critical. And you see that in most of the job descriptions, they are asking, oh, maybe an AWS certification in system ops, SysOps, or a developer or solution architect, criteria, something like that. So that's just it. So, but one question while you're explaining that, one question that came to my mind is what do you think is the basic, there are so many tools out there for configuration management, for infrastructure as code, for containerizations and all those things like that. From your own experience, what are the just basic tools, that you feel that the person can learn and you say, yes, I'm a DevOps engineer.
Okay, to answer that question, let me not just be political. So, okay, for starters, first you need to learn how to use Linux, right? That's like the basic. You have to learn how to use Linux, try to write Bash or share scripts. Then you move on to there's if you want to use Linux, that you have to be able to have a Linux environment, right? So you
Yeah,
move on to learning how to do IAC, infrastructure as code,
yeah.
to create the environment that you used to learn. And then from there, you do CI/CD to automate the creation of that environment. Then in between, you must know a cloud services. For example, you can pick AWS, GCP, Azure, or the three of them, and then know since you're using Terraform to provision a Linux machine or a Windows machine. So for EC2, and then know what EC2 is, all the compute services, the one you can grab majorly. Then you work on your the IC. From IC, you can learn coding. So you can learn Python. Basically, we use Python a lot for scripting, and then have idea of how code works, right? I think like that's like the basic,
Yeah.
yeah, to develop. Then from there, you can be picking and learning. Then Ansible too, and then Docker. Yeah, those ones.
Yeah. Thanks for that. So I can bet you that all our curriculum in Suda High it also covers all those basic things that you learn to certify yourself as a DevOps developer. Sorry, as a DevOps engineer, sorry, developer. As a DevOps engineer is very, very critical. So all those things are also covered from our own curriculum. So any other question before call it a day? I think we have had very, very, very insightful and also impactful session. All right. So if there are no questions again, once again, I would like to thank you, God's time, Bede. Once again, I'll try to pronounce Osemeke. Right, I think that. Osemeke. So I tried to I think I tried that. So I tried to want to appreciate you for your time for that comprehensive presentation. And I think for all of us both with the experienced and the people the people that are just trying to move into DevOps, be able to learn a lot of things. Like this, like giving us a little bit of background of what you should expect in DevOps and how you can also keep learning and also improve yourself in DevOps. So thank you very much, everybody. Okay, I dropped the link of the roadmaps. Someone has dropped the link of the roadmap. You can also so at least you keep track of your progress in learning it. So thank you very much for joining us today. Once again, you can check more information about School.io on School.io. You can check out we have courses on cloud engineering, on machine learning, on cybersecurity, on DevOps. So you can check out all those on our website, School.io. We appreciate you. Thank you very much from Namibia, from Germany, and from Nigeria. Those are the countries I can see. We appreciate you all. And until next time, when we'll be having another webinar on another exciting topic. Thank you. Thank you very much.
All right, bye.